Okay, so this is going over an exam question on circular motion from 2009, and this one is focusing on banked turns in a plane. So we're told that the acceleration due to gravity is 9.81 meters per second squared, and we're told that Sam enjoys flying vintage airplanes, and one of the planes Sam flies has a mass when operating of 635 kilograms. So we're given the mass here. In order to turn the plane in a horizontal circle at a constant speed, Sam tilts or banks the plane at an angle of 22.5 degrees. There's theta. The free body forces on the plane are shown in the diagram below. So we have a force due to gravity and we have a lift force. Show that the size of the vertical component of the lift force is 6230 newtons. So we're told here that it's flying in a horizontal circle. That means there must be no net up or down force. So F lift vertical must be equal to F gravity, which is equal to m times g, and we were given the mass earlier on. It was 635. That's 635 times 9.81, which is 6229.35 newtons, which to the correct number of significant figures here, which is 3, is 6230 newtons. Note that this is a show question, and I recommend giving the unrounded number first and then rounding it to the correct number of significant figures. Okay, we're then asked to calculate the size and direction of the resultant force on the plane during this turn. So the resultant force here, we'll go back up here. The resultant force is going to be the sum of the force due to gravity, which we know is 6229.35 newtons, and the lift force, which is at an angle like this. And we know that that angle here, that angle must also be 22.5 degrees. So that is 22.5. And this is the resultant force. And this is going to be, well, we know the adjacent side, and we know this, so we know F net divided by 6229.35 should be equal to the tangent of the angle. So we can say F net divided by, what was it again, 6229.35 should be equal to the tangent of 22.5. So F net is equal to 6229.35 times the tangent of 22.5, which gives us an answer, an unrounded answer of 22.5 tangent of that, which gives us 2580 newtons. So the size is 2580 newtons, and the direction, if we look back at our vector diagram here, is to the left. Okay. In another constant speed horizontal turn, the plane has a centripetal acceleration of 2.50 meters per second squared. Calculate the angle of banking of the plane in this turn. Okay, so what we should do is really work out what our triangle looks like again. So we have the weight force, which was 6229.35, was it? Yep, newtons. And we have this unknown lift force. But now, whoops, we know this one here is going to be m times AC. And we're trying to find this angle. The reason this is m times AC is that we know the centripetal acceleration, and so this little force here, the net force, must be the centripetal force, which is just the mass times the centripetal acceleration. So let's work out what that is. Fc is equal to MAC, which is 635 times 2.5, which is equal to 1587.5. And tan theta is equal to 1587.5 over 6229.35. So theta is equal to the inverse tan of that ratio, 1587.5 over 6229.35, which is 1587.5 divided by 6229.35, and then we take the inverse tan of that, and we get 14.29. Oops, I just lost my answer. Let me just do that again. What was it again? It was 1587.5 divided by 6229.35, and then inverse tan, and that gives us 14.297. So the angle to the correct number of significant figures is 14.3 degrees. Okay. For a plane to turn in a horizontal circle at a steady speed, it is necessary to tilt the plane. By considering all of the forces that act on the plane, explain why this is the case. So what we'll do is we will state that we'll ignore air resistance. And then the two forces acting are weight and lift. Okay, now these two forces are going to combine to produce a horizontal force. So what we can say then is, to turn in a circle, the net force on the plane must be towards the center of the circle. And then we can say that by tilting the plane, the lift force is no longer vertical. It has a horizontal component. Its vertical component cancels out the weight force, and the horizontal component provides the centripetal force required for circular motion. Okay, I think we've covered everything now. We've considered all the forces acting on the plane, and we've explained why it needs to tilt and how tilting is able to give it the centripetal force that it needs. Okay, so that's an example of an exam question on banking.